Sri Gurubiya Nama children, welcome to online training project Ekalaiva. Already we are discussing about electrochemistry lesson. In the previous class, I told about Nernst equation. We have derived Nernst equation for the electrode reaction, and I have worked out one problem also based on the Nernst equation. Today we are going to derive equilibrium constant from Nernst equation. So we are going to derive equilibrium constant from Nernst equation with reference to Daniel's cell. So we are going to derive from Nernst equation equilibrium constant with reference to Daniel's cell. Are you ready, children? Be ready with your notebook. Equilibrium constant from Nernst equation. Equilibrium constant from Nernst equation. Equilibrium constant from Nernst equation. Okay, let us start. In Daniel's cell, when the circuit is closed, in the Daniel cell, when the circuit is closed, the following reaction is taking place. The following reaction is taking place. So, in the closed circuit in Daniel cell, the following reaction takes place. Let us see the reaction. Zinc solid plus copper 2 plus aqueous gives zinc 2 plus aqueous plus copper solid. So this is the reaction taking place in the Daniel cell. So when the circuit is closed in the Daniel cell, zinc solid reacts with copper 2 plus aqueous to give zinc 2 plus aqueous with the liberation of copper solid. At some time the concentration of zinc 2 plus increasing, concentration of zinc 2 plus increases and copper 2 plus and concentration of copper 2 plus decreases, and concentration of copper 2 plus decreases, concentration of copper 2 plus decreases. At the same time, there is a decrease in the voltmeter reading. There is decrease in the voltmeter reading. After some time, the concentration of zinc 2 plus and copper 2 plus, the concentration of zinc 2 plus and copper 2 plus becomes equal, and the voltmeter reading shows 0. At this stage, equilibrium is attained. At this stage, equilibrium is attained. What is equilibrium? Balanced state. Equilibrium is attained. Balanced state is attained. What is that we are seeing now? The Daniel cell, if the circuit is closed, the following reaction is taking place. What is the reaction? zinc solid reacts with copper 2 plus aqueous. So what is that we are getting? Zinc 2 plus aqueous with the liberation of copper solid. So what is happening? In the beginning, the concentration of zinc 2 plus ion increases and that of copper 2 plus ion decreases. So zinc 2 plus ion concentration increases in the beginning and the concentration of copper 2 plus decreases. And when you talk about the voltmeter reading, the voltmeter reading also decreases. There is the decrease in the voltmeter reading. After some time, when you see the reaction, what is happening? The concentration of both zinc ion as well as copper ion becomes equal. So, after some time, when you look up the concentration of zinc 2 plus and copper 2 plus ion, both are found to be equal. At the same time, when you note the voltmeter reading, it becomes 0. You can see the 0 reading in the voltmeter. It shows that an equilibrium is attained, a balanced state is attained. So, we are going to derive the equilibrium constant from Nernst equation. So, I have talked about the Daniell cell where the circuit is closed, the reaction has taken place. In the beginning, the concentration of zinc 2 plus ion increases and that of copper 2 plus ion decreases, but the voltmeter reading there is a decrease. But when after some time, when you see the concentration of zinc 2 plus and copper 2 plus, both are remaining constant. At the same time, the voltmeter gives 0 reading. At this time, what can we infer? Equilibrium is attained. Now we are going to derive equilibrium constant from Nernst equation. Okay children, let us continue with the next part of the, what is that, equilibrium constant from Nernst equation. Okay, I am going to continue with that. So here EMF of the cell will be 0. E cell EMF of the cell will be 0. What is the Nernst equation? E cell is equal to E dash cell minus 2.303 RT divided by NF log of, what are the products and reactants here? Log of copper, what is that? Log of copper divided by, what is that? We will be getting zinc and copper, zinc 2 plus. So, what is that? You will be getting, what is that? Zinc plus copper 2 plus, they give zinc 2 plus plus copper, log of zinc 2 plus by copper concentration. So, what are the reactions? Zinc plus copper 2 plus gives zinc 2 plus copper. So, log of zinc 2 plus divided by copper 2 plus. So, what is that you will be getting? E cell is equal to 0. 0 is equal to E dash cell minus 2.303 RT divided by NF log of zinc 2 plus by copper 2 plus. So, when you bring this E dash cell towards the other side, it will become negative, is it not? So, E dash cell is equal to minus 2.303 RT divided by NF log of zinc 2 plus divided by copper 2 plus. Okay, so minus minus getting cancelled. So, E dash cell is equal to 2.303 RT divided by NF, where I am taking concentration of, what is that? Zinc 2 plus divided by copper 2 plus. I am taking it as Kc, which is equilibrium constant. Which is equilibrium constant. So substitute Substitute this Kc in the above equation. What you will get? For this quantity, I am taking it as log of Kc. So, after substituting the values of, after substituting the values of, what is that, R, T and Faraday in the above equation, the Nernst equation will become E dash cell is equal to, what is that, 0.059 volts divided by 2 into log Kc. So, after substituting the values of R, T and Faraday in the above equation, we will be getting standard cell potential E dash cell is equal to 0.059 volt divided by 2 into log of Kc. What is Kc here? Equilibrium constant. So, I have taken Daniell cell as a reference cell and I have talked about the, what is that, equilibrium constant. I have derived equilibrium constant from Nernst equation. So, I have written the cell reaction that is taking place in the Daniell cell and I started to find out the EMF as 0 and I have equated this in the Nernst equation. So, I got E dash cell is equal to 0.059 volt divided by 2 into log of Kc, where Kc is the equilibrium constant. So, in this video, I have explained the equilibrium constant derived from Nernst equation. So, if you like this video, you please click the subscribe button. You will be getting the latest updates. Thank you, children.